Thank you everyone for coming to the second workshop in the Masterclass series of Comparative Cloud Technologies. This week, we will be doing networking and processing in the cloud, presented by the esteemed Tim Jones over here. So just some quick housekeeping just before we begin. Oh, my name is Jack, by the way, and Jack Stewart, and in the administrative or, just making sure everything runs smoothly roles this evening, we have Hannah and Kit as well from IT Masters. Thank you very much. So yes, just some housekeeping before we begin the official webinar. We really do encourage you to use the chat and the Q&A functions in the in Zoom to engage with the webinar. So all questions that are relevant to the course content, so about the substance of what we're actually kind of learning about, what Tim's talking about, can be directed to the Q&A section. And then administration type queries, as well as general chats, can be popped in the chat section. You can select for just the host and panelists or for everybody to be able to see your messages in the chat section by navigating to the drop-down menu in the bottom, just above your type message section in the chat, and selecting everyone. And that way everyone is able to chat with one another in that chat log. Keeping in mind as well that there are probably some very, very experienced attendees who, with a lot of, industry knowledge as well in the chat, who might be able to offer some really unique insights as well into some of the materials that we'll be discussing. And then we'll be opening up questions periodically throughout the webinar, as well as going through at the end. So we will, be directing some of those to Tim throughout the webinar. So as I mentioned earlier, Hannah is here from IT Masters doing admin and tech support, as well as Kit, and they are responsible for the learn.itmasters.edu.au website, which is where you can find all of the materials that are necessary for this course. So the readings, the discussion forums, the quizzes, as well as links to recordings of previous webinars. And then also you can use that page to contact us. Feel free to contact us using that page throughout the week if you have any other questions. And you can also direct inquiries to short courses at itmasters.edu.au. So with that all done, without further ado, I will turn you over to the esteemed Tim Jones, who's going to take us through networking and processing in the cloud. Take it away, Tim.
Hey, how you going? Thanks very much, Jack. Thanks for the warm welcome, and welcome everyone to this session of the Masterclass series. So this week we're going to be going into a little bit more technical detail around the networking and processing side of cloud, and a bit of a demo of how those things come together as well. So to get things started, just to begin with that, again, this is the second of 4 sessions that we're running through. And as Jack mentioned, we have all of these recorded and they go up on YouTube afterwards. One of the really good things there is that there's the full back catalogue of all of the IT Masters courses that are on YouTube as well. So if you see any interesting videos in there, you can sign up to some of the other short courses or Masterclass series that we have as well. So what we're covering this week, I won't go in detail here, but this is what we're covering off. So to look at one of the things that that came up of interest during the week, we had some pretty active stuff coming through on the forums of people asking questions, a whole bunch of people answering questions. And so we had great resources that was put up by one of the students in the chat. So recommend that people check this out. From a comparative perspective, this is probably the best sort of layout and view of information that I've seen, of giving you information across AWS, Azure, and GCP for what's happening in the cloud space. So there's a link that's in here, but also there's a message from Grant that's in the forums. I think it was Grant or Steve. one of the two anyway, that was in the forums. And so, yeah, please have a look at that if you're interested to see how the different capabilities of the cloud environments stack up. As I mentioned last week, as soon as someone comes up with a good idea in providing cloud application capability, the other major providers very quickly follow up with the same sort of capabilities. And you can see that here by there's a large number of equivalent capabilities across the major cloud platforms. So to launch into now having a look at how is networking delivered in the cloud. All right, so what we have first of all is one of the really important things to remember for doing any sort of IT course, but in particular when we're starting to deal with technology in the cloud space, is that we need to have a solid understanding of standard networking. And the backbone of standard networking today is TCP/IP. So we use that across the board for all of the systems that we utilize. We don't need to know any other real protocols these days other than TCP/IP. In the past, we would need to know some things like NetBIOS, IPX, SPX. We would need to know AppleTalk. We might need to know SNA or something like that. But these days, everything is running through TCP/IP. So networking has become somewhat simpler, but it means that you need to know it quite well to get the networking outcomes and have resources able to be consumed, especially in a cloud environment. All right, so as part of TCP/IP, what we expect that people are going to know and understand is the ideas and concepts of things like DNS, or domain name system, or domain name server, that provides a naming system for converting the things like itmasters.edu.au into an IP address that you can send traffic to and from. We expect an understanding of ports. So when we have web traffic, standard web traffic, we're traveling on port 80 or connecting to a secure site on port 443, and understanding what happens with ports and how they operate. We expect an understanding of routing. So what we mean by routing is connecting multiple networks together and being able to send traffic between them. So we have routing tables that help us control that, and things like default routes of how we send traffic out of the network and to other spaces like the internet. The concept of subnets, or how we have separate network environments that we connect to across the board. So we have a collection of servers, systems, or capabilities that have IP addresses that sit within one network segment, and they don't need to route. They can go through and have information sent directly to each other over what's termed as a local network. So a subnet is a bunch of machines that sit on a local network. And gateways. Gateways are things that allow us to connect out of our network again, and ties in with subnets, with routing, and potentially with DNS as well. All right, so if all of those sort of things, if there's a bunch of things that I was talking about there that didn't make a lot of sense, right, and you're interested in learning more about TCP/IP networking, how it works, and going into a deep dive on that sort of capability, you'll see a link in the bottom right-hand corner of the screen. So we've actually got one of our IT Masters courses, ITE 526, which is Practical Internetworking, where go very deep into TCP/IP, into routing, into switches, and the capability to send information across the internet, across networks, connect networks together, etc. So one of the courses, recommend that one. As far as what we operate both within the cloud and within our larger environment, it's still mostly TCP/IP version 4. So this is where we see addresses that look like 192.168.16.2. Right? So that's a TCP/IP version 4 networking address. When we're talking about TCP/IP version 6, there's a big string of hexadecimal number that gives us the broad IP address for a TCP/IP version 6 system. Now, the reason why that was put in place was, especially coming through the 90s, the whole world was running out of TCP/IP addresses. And so a new standard was brought into play that was going to use 32 hexadecimal bits to allow us to have a much wider range and an inexhaustible supply of IP addresses so that we can connect to anything, anywhere. In the interim from then, there's been a big change from a networking perspective from the 90s that public addresses, the addresses that are accessible directly from the internet, have become much more available as companies have freed up their private address pools, and they use private, specifically private addresses for their internal networks. Right? So that change has meant that the loss of the internet addressable IP addresses has not run out, and doesn't look like it's going to be running out anytime soon for standard websites and things like that. So there hasn't been the big push to move to TCP/IP version 6. And so we don't see that as a big requirement for what we're doing with Cloud Things. Now, where you will see TCP/IP version 6 is when we start to look at the backbones of the internet, which we're not dealing with. And in particular, when we start to look at very large scale IoT systems, where it makes sense that we want to have them each be individually addressable, and we can't give millions of addresses to a whole bunch of devices. But for the intents and purposes of dealing with cloud networking and cloud delivery, we can mostly ignore TCP/IP version 6. Right? So good news for anyone who hasn't gone deep into that at the moment. Right. So just as I go through this, there's a question that's on here from Naylan, and he asks, what are examples of gateways? So a gateway is basically a connection on your network that connects to another gateway. So that could be a router, or it could be a device that provides connectivity to the internet or something like that outside of your network connection. So within your own home network, many of you are sitting at home at the moment, you've got a router device that runs Wi-Fi that has a gateway address on it. So that's a local address that's on your own network. So you've got a subnet within your own home, and that subnet has the gateway that provides access to every other network, right, as a standard thing. So we've just got that gateway address that gives access to every other address that isn't on your own network. All right. So when we're looking at cloud networking, we can run our applications completely separately. We don't need to connect to any other networks or anything like that to have applications run in the cloud. So for example, if we're doing medical research or something like that, where we have a large data set that just requires compute power to run over that data set and give results, we don't necessarily need to connect to anything else. We just need to have the data set available and to run the compute capability. Generally speaking, when we're looking at the capabilities within a corporate enterprise or something like that, we expect to have some connectivity from within the normal corporate office or data center environment and connecting into the cloud environment. So that's quite a normal aspect. And to provide that capability, there's two major ways that we do it. So there's a VPN. Usually we normally run an IPsec VPN that connects our network environment in the office or data center into the cloud environment, and we would do that with a VPN over the internet. Right? So so all of our traffic that's going to and from our office to the cloud environment is traversing the internet, but it's all very secure because it's sitting within a VPN and IPsec tunnel. Right? So the other way that companies often do it as well is to have a dedicated link. So If we're talking AWS world, this is called Direct Connect. If we're looking at Azure world, this is called Express Route. But they're exactly the same sort of thing. What they're doing is they're providing network connectivity using standard sort of direct networking capability, so provided by someone like Telstra, and it can be as much throughput up to 10 gigabytes connections that we have between our data center and the office. If we need to make sure that that link doesn't go down because our applications are talking backwards and forwards between the cloud and our data center, for example, and we have mission critical systems that need to be up between that, we would have a redundant link between it. So we might have two 10 gigabyte links that are going between our data center or multiple data centers and through to the cloud environment. What we see more often for a lot of customers is they will have a VPN backup. So they'll pay for a dedicated link, usually not as big as a 10 gigabit link, because that size of link from a dedicated network connection is quite expensive. So you're looking at tens or hundreds of thousands of dollars a month for high throughput, high capability links from a data center into a cloud environment. Having a VPN as a backup means that we can't run any faster than our internet link, and it can cause some other problems, but it's a good way to provide the capability of failover and to keep things running if needed without having a huge expense put into deploying those things. So that, as I said, a pretty standard sort of deployment methodology. Now, what we have within those cloud networks is we have software-defined networking. So we've got the links and capabilities that are set up within a multi-tenant environment on the cloud platform side. So sitting behind all of the way that the cloud providers work, whether it's Azure, whether it's AWS, whether it's Google Cloud, any of the platforms or any of the other players. So that had some people mention on the forums, things like the Oracle Cloud or IBM or Alibaba, any of the other cloud environments. They're all sitting there on the back end with a hypervisor platform. And that might be, so the workloads and the capabilities and the SDN and all of the other technologies that are provided, sitting there with a hypervisor that's sitting there like VMware, that might be the Red Hat, it might be KVM, it could be another platform. Right? So there's various ones that are in use. Microsoft, obviously, there'd be a bunch of Hyper-V and other capabilities sitting behind there as well. But it's hypervisor technology with a multi-tenant capability sitting on top of it that, as part of that, provides the software-defined networking for capability of internal networking for the client, but also separation of that networking capability from the other tenants that are using the same infrastructure. So within that SDN, we can create subnets and other connections within the site, and that allows us to create quite complex networks as required. So what when we access those resources, they're tied to our network or they're accessed directly via the internet. Right? So there's a difference in that. So if we create a virtual machine, if we're using AWS as an example, we create what's called an EC2 instance. EC2 because it's elastic cloud compute, which is what they call their virtual machines. So you're basically just creating a virtual machine in the space that needs to be connected to a subnet or a virtual network space, what's termed as a VPC in the AWS world. And it can then be connected directly to the internet, or it can be connected as well to the internal network. But when we start to look at other resources within those sites, so if we look at something like the Amazon S3 capability for having file access, by default, that's accessed over the internet. So we need to leave the bounds of our network, go out onto the internet and connect back again. So we need to be aware of what those connections look like, what the needs of our applications are when we're designing and controlling the rights that users and applications have within our network. So our client systems can access from within our network via the internet, using load balancers or CDNs or anything else. So there's a whole bunch of ways that people can access things across there as well. All right, so just want to check through. Was there any pertinent questions? I haven't kept track of what's come through there, Jack.
There was one that you did indicate that you would like to answer. And if you
that was
did you kind of get
yes,
you did.
Yeah, that's one. That's the
Yes.
The gateways one.
Yes, it was still in there. I was just going to quickly remind people as well, there are there are a couple of questions that are coming through in the chat that are fairly relevant to the kind of technical content of the webinar and things like that. If you'd like to put them in the chat and have them answered by by the other people in the chat and who are participants in the course, that is absolutely fine. But if you're hoping to have your question answered by Tim, then the place to pop that is the Q&A. But very, very happy to see the discussion going on in the chat as well. I think that there are a few other questions that are possibly covered slightly down the track in here as well.
I'll answer a couple to start with here. So there's one from TN. Does Direct Connect or Express Route use traditional transmission methods such as DWDM, SDH, etc.? So just to answer that, so what's being asked here for people who aren't au fait with networking technology is, are we using the same sort of links that we might use to connect side offices for a regular business? So having a leased line from Telstra, in the old days, it could be very long ago, showing my age, it might be ISDN or frame relay, but then we have DWDM as new technology or newer technology and capabilities that provide that linkage. And so yes, in the back end, there's a whole range of capabilities and technologies that are used. But what you're doing is you're signing up to a provider to provide that link for you. So you get basically an endpoint within your network that goes to an endpoint within the Amazon or Azure or GCP or Oracle environment, whichever cloud environment you're going to. There's an endpoint at each end. You don't need to worry too much about what that link looks like because you're buying essentially a point-to-point connection, and how that's delivered, generally speaking, you're not too worried about. In some cases, for very large organizations, you might be looking at things like dark fiber or something like that as a backup, or some other cases. But generally speaking, yes, we're using standard networking technology to provide that link. And when you're purchasing the link, you don't worry too much about it. For the most part, it's using some form of fiber for most of the link that goes through, but how the endpoints connect through from a networking provider perspective don't matter too much. The other question I'll answer here is, how would you define a software-defined network? All right, so this is where we come to a lot of the crux around not only software-defined networking, but moving into the whole DevOps, DevSecOps, DevSec, AI ops, and all of the capabilities that come along with that. Right? So generally speaking, one of the things that we're looking at is infrastructure as code. So the expectation here is that we're not using physical connections to define our network. So yes, we still have physical connections that connect devices together. We can't just plug servers into data centers and have them just automatically go through and use software-defined networking without any physical connections or air-based connections or whatever the case may be. But when we're looking at software-defined networking, those physical connections don't define the links. The other side of it is the expectation of us being able to use APIs. Remember, APIs are application programming interfaces, or using CLIs, command line interfaces, to access and control how we're deploying and managing those things. Now, once we get to the point of being able to use APIs or CLIs to deploy, manage, and control our networks, that gives us the ability to manage all components of our network or our other things that we have as infrastructure as code as digital assets. And the big advantage we have there is that things like change management then become much easier. We can be much more assured of the quality of the systems that we're putting in place because it's been tested. We don't have a human doing checkboxes or physical connections to make the individual points, etc. So software-defined networking, again, we don't have the networks defined explicitly in the physical world, and we've got APIs and or CLIs that allow us to access them. Cool. All right, so now to launch into network security. Excuse me a moment. So when we touched on this last week, but our responsibility that we have from a cloud service provider perspective for any of them, right? So whether it's one of the hyperscalers, whether it's someone like Dimension Data, whether we're looking at someone like Datacom, Oracle Cloud, any of the platforms that might be out there. The expectation is that the cloud provider is going to look after, first of all, the physical security of the data center. So we're not expected to post our own security guard out the front or do any checks to make sure that people are going into the physical environment. The other side is that they provide the multi-tenant environment. So I touched on that before around what that means. So when we're talking about multi-tenant, this is the ability to have more than one user using our data center, right? So if we can only have one user connecting into the equipment, then we're not doing cloud, we're doing co-location, right? And that's quite a reasonable outcome. There's still a whole bunch of companies that use co-location to do so. Data centers like Equinix, they provide co-location facilities to allow companies to host servers, hire servers, or anything like that in a cloud-like environment. But if you're not in a shared environment, as far as a separation and multi-tenant type view, you're not really in a true cloud environment. We expect to see the provision of capabilities, tools, education more around the security space. So there'll be some capabilities of what they provide to their users around allowing them to keep their environment secure. And we see a lot of things in that space. So if we go back to that list that I brought up before of the comparison between the three cloud environments that we're mainly touching on here, then you'll see there's a whole range of things from a security perspective that the different providers have as well. And the other thing that we expect is that when we deploy something, just using the default settings, is that it's going to be mostly secure. All right, so the expectation is that if we just click, 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 we don't have someone able to immediately get into our systems, get hold of them, start running spyware or crypto miners or something like that on there. Right? So the expectation is that there's a level of lockdown or thought around how you deploy these systems by default, because one of the big problems that cloud service providers have is the users themselves. Right? So people will turn up and use these things without necessarily having a lot of thought about security. And so making things by default secure, it protects users from themselves. So as part of this, we have the risks, right? So one of these is potential hypervisor breakout. Right? So what this means is there's been a demonstration made by academics of the possibility of being able to gather information from another tenant that's sitting on the same physical server as you. Right? So you're separated, but there's some theoretical, at least, capabilities of being able to break out of that multi-tenant environment within the hypervisor that you're running on and gain information, control, or otherwise, even if it's just a denial of service attack, to cause some form of harm, gather some data or something else from a hypervisor breakout attack. Right? So there's a risk there. It's, again, mostly at the academic level because one, it's not at all easy to do. Two, it's something that the cloud service providers are very aware of as a possibility, and they've got their own controls capabilities to both make sure it doesn't happen and detect anyone who's trying to do that sort of thing. And three, you have no idea or control over which systems you end up on. You don't even know which data center you're going into when you're looking at a region. Right? So you don't know where your data physically resides. You don't know who else is running on the system. So you can't target a particular user or company in any effective way by using this sort of attack. Right. So the other risk is incorrectly configured access. Again, this is a people issue. Right? So this isn't just looking at cloud service providers. It's something that's everywhere. The problem that we have in the cloud is having people that are responsible for administering the cloud that haven't been adequately trained in security or the technology that they're managing. And so they're either provided too much capability, they might delete certain resources that they shouldn't do, or grant access to the internet to certain things. Right? So in that case, we again want to make sure that we have people coming along to this sort of course and getting some broad understanding. But when you're working as a cloud administrator, the expectation is that you go through and have some deeper understanding of what the requirements are to deploy technology and manage it in an ongoing basis. So within our cloud environments, we have multiple layers or capabilities from a security perspective, as well as the user management and role-based access control, which is pretty standard across the board. We also have firewall capabilities. So this allows us to provide basically a wall that sits in front of our network environment and checks to make sure that only the traffic is coming through that we want to go through. We got things like security groups that allow us to do something similar to firewalls, but on a subnet by subnet or application by application basis. We've got access control lists or network access control lists, and these allow us to set, again, similar to what we're doing with networks, but what IP addresses can access certain components, what network ports that can come through, and what can travel in both directions. So these are also known as NACLs or ACLs for how we provide rights to certain systems. And then we've got various other security tools. So as part of the security tools, we have the ability to do things like health checks from security, where we have cloud service provider tools that will go through and check who has rights to what, making sure that you've got adequate role-based access control and that you don't have public rights to systems that shouldn't have it. The other side is that we've got distributed denial of service attack protection capability, and CDN, which is the content delivery network, which spreads out our network load, especially for large scale deployment of websites and capabilities to large numbers of users. And this allows us to make sure that we've got a broad enough face on the internet that if individual components of it are taken down by a very concerted attack from a distributed denial of service attack, that people can still access our resources. All right, so that brings us to the end of security. So if I just have a look through here, was there anything that you saw pop up, Jack, from a security perspective that I should look at?
Yeah, there are a couple of questions. I'm interested in Ann_DV has asked, what are your thoughts on a zero trust approach for network security?
Yeah, so this is one of those things where we're deploying our systems and managing our systems from a perspective that nothing is deployed in a manner where we expect the need to trust any other link in the chain. Essentially, I think I'm explaining it correctly. So the view is that when we're deploying applications, we provide each component in there is not reliant upon other components in the chain so much to provide its own security. And so this means that we end up with an overall security stance, which is much stronger, because anything can still be broken into. Like there's large scale systems, nation states that secure environments, and they can still get hacked into, even though they spend millions or billions on securing the environments. But if you make it hard enough through enough separate controls and securing each step of the way that someone needs to get to the pot of gold, whatever that may be, whether it's data, whether it's bringing down your network, whether it's gaining access to control an application, deface a website, whatever it is. If you've got enough things that make it onerous or too timely, either you'll be able to detect the attack before it actually goes through, or you'll be able to go through and stop it or patch it before they manage to complete the attack. Or you make it so expensive for them to carry it out that it's untenable for them, except for, again, nation state actors.
Right. And I think also, thanks for that answer, by the way, Tim. I think also just leading on to that nice little segue, Ray Werlod has asked, how can cloud service providers guarantee that data remains in country, and how can that assurance be audited? And I am sorry for picking the legislative or kind of, regulatory questions about that, but I'm really interested in the regulatory questions. I promise that I will let everybody else hear about the more technical questions in a little bit.
Yeah, so I mean, regulation is a huge thing. Like whether you're looking at banks, of governments, or other entities, there's a big push both within Australia and anywhere else around the world to ensure that we have data assets sit in country and don't go out of it. Right? And so one of the large parts of this is understanding the architecture, first of all, of how the technologies work. So again, going through and going in depth into the architecture of one of these cloud platforms that you're using is very valuable to understand what they do under the hood. So for example, if you've got large amounts of archived data that need to be kept for 7 years for a government entity, or heaven forbid, you're working for the NHS where it needs to be kept for the life of the member plus another 100 years or something like that. You want to have policies in place to protect that data, to make sure it doesn't go overseas, but understanding what happens behind the scenes and how the technology works, how it backs up itself, how it replicates, can give a level of assurity and comfort to the business. And having using internal tools within some of these cloud providers can also mean that you can have some additional assurity. Again, part of this is needing to trust the cloud providers that they're doing what they're saying they're going to do, because you have links between all of the data centers within these cloud service providers. And if you don't trust them, then they could be sending you data anywhere in the world. But again, understanding the architecture of what it's doing underneath, understanding that they work with compliance and these needs all the time, and using the tools that are built into their capability to meet your own requirements can give you a level of comfort. And from an audit perspective, you can see where that data has been copied, etc. Right? And to a certain degree, again, from a compliance perspective, we've got, in some ways, in some situations, we have more control and comfort around how some of these things work than we do by using traditional methods in the real world. So going back 5-10 years, we would back up all of our archived data to tapes, and they would be physically transported to a remote location. Now, once those tapes were offline, it would be possible to copy them. Even if they were encrypted, they could go to somewhere and be decrypted given enough time. Right? So knowing that the capabilities are in place and the technology is in place for how information, again, is sent around can mean that if you set these things up correctly, it's possible to make sure nothing else happens to them. The other side of things is using your own encryption keys, using hardware security devices and other encryption capabilities to make sure as well, even if it does go overseas, if it's sensitive data, there's no way for anyone to do anything with it.
Great,
Right.
thank you.
Cool. All right, I'll launch into servers. So thanks everyone. Now, when we're looking at servers in the cloud, so first of all, what we're looking at here is, again, essentially virtual machines. So if anyone's had anything to do with VMware or Hyper-V or KVM or any of the other platforms, Zen, Open, any of the other platforms, you can run virtual machines anywhere, and virtual machines run in the cloud in a very similar manner to what we have in your own hypervisor environment. Right? So if anyone's running Windows 10, you can run up a virtual machine on your platform. The way that we deploy those systems is based upon a CPU type, first of all. So generally speaking, and traditionally, we've deployed Intel-based virtual machines in the cloud. But one of the things which is becoming much more common and is a preference in some cases is utilizing AMD-based processors. And what this means is AMD processors, the same sort of thing that you have within your mobile phone. They're lower power, so you don't need as much cooling in the data center. They've got high throughput, high capability, and they're smaller, much cheaper to actually run. So the server, the same CPU cycles or the same amount of processing on an AMD processor would often be considerably less costly than running an Intel processor. So the cloud service providers can then give you cheaper virtual machines if you choose to run on that platform. The number of CPUs you can choose as well. So generally speaking, if you've got a really simple website, you might just need a single processor. If you're running a SAP HANA environment, you might need 64 processors or something like that. So a very wide range. And so we can choose the different systems that provide us these different capabilities. The amount of memory that's involved. Again, we can go anywhere from half a gig of memory within an environment, running a very simple system, up to running multiple terabytes of memory, again, for something like SAP HANA running in the cloud, and networking and other components. So the other side that we look at, as well as what we're deploying in the way that we would with a virtual machine within our own hypervisor environment, is that we also look at the lease type. How are we buying this virtual machine? So the first one is that we can have what's termed as spot instances. Right? So the spot instances means that there's excess compute load, and people will essentially do a reverse auction for buying these spot instances. So say, for example, if you were looking at doing crypto mining, you'd worked out that right now, if you buy a particular virtual machine for 30 cents an hour, you can make more money doing crypto mining than it costs you the 30 cents to essentially hire that virtual machine. You can specify in the console for one of these systems that as soon as the price drops below 30 cents, that you want to start buying spot instances to go away and run your crypto workload. So that's the type of thing that we look at when we're looking at spot instances. Something that doesn't require a long-running system, that has processing that can be done in chunks or various times, and that we're not worried once it gets shut down, because as soon as the price goes back up over that 30 cents, we don't want to be running it anymore. The other type is just instance. So this is just a standard thing where we're paying a price. Again, this might be $1 an hour or something like that for a server. So keep in mind with this when you're looking at playing around with cloud environments, doing training courses and things like that, of the costs involved. So one of the things that I do, I'll go through when I go into a demo in a minute, is I set up all my virtual machines so that they have basically a self-destruct. So they don't keep running for a long period of time when I'm learning with them. Now, in the lab environment that you've all got access to, you don't need to worry about it from the AWS side. So you can create virtual machines in there without having to worry about the overall cost. But when you're using your own credit card, you want to make sure that you don't end up with a nasty bill at the end of the month. So it's happened to me a couple of times of $150 odd bill or something like that from something that I wasn't actually using, but I'd been playing around with for a training course or to get a demo working or something like that. So keep that in mind of making sure that you, as much as possible, you have things set up so that they'll self-destruct or alert you when the cost goes up over a certain threshold. The next type along is reserved instance. So a reserved instance is where we've said, well, you know what, this is a virtual machine that we're migrating from our data center and we want to have it now running in the cloud. We know the life cycle of this application. We want it to run for the next 3 years, and we'll then look at maybe shutting down the server at that point. But because we want it running for 3 years, we don't want to pay the same hourly rate as someone with a credit card turns up and just starts running a virtual machine. We can get a discount from our cloud service providers for a reserved instance where we say, well, we're going to keep this system running 24 hours a day, 7 days a week for 3 years straight, and you can get a discount of up to 75% for running a system like that. Finally, we have dedicated. And dedicated is where we're running in the actual, our own physical equipment. Now, the reasons that we would do this, if we come back again to a platform application type such as SAP HANA, where we need to use the entire system's capability for managing our database access, for example, because we need the whole performance of the system. So we have a dedicated environment there. The other one might be that we're really worried from a security perspective. We might be a defense organization, a bank, or some other system that doesn't want to take the risk of the type of risk that I was talking about earlier of hypervisor escape. Right? And so you want to run certain secure systems on your own dedicated platforms. Now, those application types will, that type of instance will cost you a fair bit more money because you're not sharing the platform overall. You've essentially getting a physical system for you to use within the cloud environment. And then we have got predefined operating systems that are part of the deployment for these as well. So Linux is the most common. So that we see these all the time for building blocks for applications. We get them, we start them up. It makes it pretty straightforward for us to access the applications, the application type, etc. The Windows, if we're running Windows applications or we're migrating virtual machines to the cloud, we can run Windows in there. And we've also got Mac OS X, which is available. So this is particularly useful for people that are doing things like testing applications. You want to be able to test across not only the server types that you're using, but you want to be able to test the clients as well. All right, so just a quick demo. Now, if I come across here, what we have is, so this is just looking, first of all, at the AWS platform. Now, what I'll do first is, if I come over here, I'll come and have a look at these. So I've created, you can see here, I'm using GitHub. I mentioned earlier about having digital assets for the way that you deploy applications and make applications available. So utilizing GitHub is a useful way of making sure that you've got the commands and other components for deploying applications available to you. All right, so if I come across here, one of the things that we can do, this is looking at the Google Cloud platform, is we can start a basically a code instance, a terminal, a cloud terminal that allows us to run command line type scripts within a cloud environment. And so this is what I'm doing here within this platform. And I'm telling it to go away and create me 3 virtual machines, basically make some systems available for me to run on. And this is building the environment that I would utilize within my containers and virtualization course. So creating the systems that I need and making sure that I've got all of the resources that are available. So this will go through and create 3 separate machines. It'll create them using Ubuntu 18.02 LS or something like that. And it will create them with Docker installed, with GitHub, with my repositories and other information and stuff like that on there as well. All right, so all of that stuff's available. And again, I'm using the standard information, so it's the same each time. Now, if I come across to AWS, I can go through to EC2 and tell it that I want to create a new instance here as well. All right, so within here, I can select that I want to create a virtual machine, but I just want to use a standard system. And here as well, I can come into here and look at my Amazon install script. So I can copy the information out of here and put that into the information. So this is basically a startup script that will run on the system. And again, if we look at the information of what I'm doing here, I'm telling it basically to update the system, to install Docker, install Nano, to put Git on there as well. To start Docker, I'm telling it to go through and then clone a couple of GitHub repos onto there as well. So creating a system that's ready for using with Docker as a system to push across.
Tim, just
yes.
really quickly, while we're on this screen or similar ones, is it possible for you to maximize your screen or just increase the size to make it a little bit bigger and easier to read? Yes, that's brilliant. Thank you so much.
Yep. Thank you. Yeah, so if we come back over here, there we go. If I have a look at system here at the instances, you can see that I have a server that's up and running. Sorry, I'll just zoom back out a little bit. refresh that. So now I can see that I've got my virtual machines up and running. If I have a look at Curly, I can bring up a terminal to see what's actually running on there right now. So the virtual machine has been started, it's up and running, it's available, it's accessible from the internet. I'm using SSH to connect to it. All right, so it's all reasonably straightforward on how we get access to this from the Cloud Console. While that's connecting, there we go. So if I have a look on here, I can do top, and what this tells me is what's running at the moment. So this is just having a look to make sure that it's not still doing the install functions that I asked it to do before of installing Docker and things like that. So if I have a look at the root directory, I should see a Git directory, maybe not. So it may not have. No, that's right. So the install script on that hasn't run through, but you've got the capability to push all of this sort of stuff across. Now, this is well looking at using digital assets to deploy these things, but this isn't the way that you would deploy these in a real world environment. Right? So this is a test lab. This is me building up things for demonstration. But as someone mentioned, utilizing something like Ansible or Puppet Chef, using Terraform or some other platform that interoperates with infrastructure as code and makes a repeatable way of managing those things would be incredibly valuable for deploying your applications. Finally, if we have a look at the Microsoft view, we can come in here and we can tell it that we want to create a virtual machine, and we get the similar sort of options and capabilities of how we want to deploy the system as well. All right, so we have different interfaces across each, and you can get free tier accounts for a certain level of use for all of the platforms, but it doesn't take too long once you start using one of the systems to learn how to get around it and use the systems. Again, you've got the big advantage with the AWS platform. You don't need to pay for anything for using a real world view of accessing the systems. You just curtailed on what you can actually use on a day-to-day basis from being able to use the full gamut of application components. All right, so finish with the servers. Just having a look through the list here. Do we have any questions? There's a question about Docker and Kubernetes. I'll get to Docker at the end of the course. Now, can you create a question from Grant? Can you create VMs from the GUI and then clone their creation to the corresponding CLI code? Kind of like how you can create DB tables and then use SQL Creator tool to provide you with the SQL string that did like you did in the GUI. So as far as creating Vim virtual machines in the GUI, yes. So the way that I created the platforms, so if we're coming back across here, if you have a look at, if I go into this and we look at my G-Cloud information, this information that's in G-Cloud, this is all comes from basically creating a virtual machine and cloning all of the settings. So I didn't type all of these things in. I created all of this using the GUI exactly as you're saying, and then it gave me all of the text that I need to actually create everything as is. So it took all of my settings and things like that and created the startup text. And a question from Alex, is Spot similar to load balance? So So a spot instance is a full virtual machine, but the way that you purchase it is based upon essentially an auction cost of what the demand is for spot instances at that time. So generally speaking, a spot instance will be cheaper than running an equivalent normal instance, and it'll be based upon what people are willing to bid for it. And if no one else wants it, you could potentially get it quite cheap. But as soon as it lowers down to a particular cost level, that's when you get it. So spot instances is all around the financial model of how you access it. When we look at load balancing is basically having a connection coming in and sharing load across multiple machines. So we can link load balancing to spot instances, but they're not directly related on a one-to-one basis. Yes, ARM processors. What did I say? I'm getting confused. So there's a question here. Do you mean ARM processors? And yes, that is exactly what I mean. So what did I call it? AMD, yes. So not AMD, Intel, ARM and Intel. So my apologies to everyone that was really confused when I was talking about AMD and Intel. So a brain fade moment from me that I meant ARM processors and not AMD. All right. Now a look at serverless. Thank you. Missing the R. So obviously I'm missing my my ability to function and spell and work out proper things today. So I'll make sure that is updated, those couple of things for what we put up. Thank you. So when we're looking at serverless, we're looking to run code natively within a cloud environment. So it's our code that's important. There's certain different platforms depending upon the application landscape that we're using, whether it's Azure, GCP, or Amazon. The programming interfaces that we use are specific to the platform. So for AWS, for example, we can use something like Node.js. We can use Python, a couple of other bits and pieces from a programming perspective, but we need to be using those languages to deploy the application. Now, what that means is that we no longer need to actually run infrastructure 24/7. We can actually have our code sitting there waiting, either with connected to an API gateway, connected to an S3 page, connected to an event, a queue, another component within the environment. And we don't need to have pay for an EC2 instance or another thing within our environment to sit there and wait and listen for traffic to come in. All right, so it allows us to save a heap of money, but one of the other things it allows us to do is to scale massively. So we can scale from home use, as an example, excuse me. As an example, this is what Alexa code looks like running with Lambda. So this is, I had to play around with this a couple of years ago.
Tim, just again, sorry to interrupt. Are you able to just increase the size of that as well? Thanks so much.
Yeah, thank you. So what we have here is a view of what the code looks like for running a Lambda application for working with an Amazon Alexa. Right, so making your own type of thing. In this one, it was interacting with an S3 object and being able to give you feedback based upon what was in there. Now, this is pretty simple. This just runs at home. But as I mentioned, the scalability is such that we can take something that is running just for a small number of users or our very first implementation of an application, and it can scale out to millions of users really quickly. So if we're building application infrastructure for a new app or some component of the game, we can scale to essentially any number of users and requests that are coming in live. And the other side of things, I mentioned this a moment ago, the ability to interact with other cloud platform components. So within the application, it can be started when we have an event from another system. So that could be an audit trace, it could be a message queue event, it could be a notification from other system, it could be a web server request or something else. And it can output information to other components as well. So we can build applications that are incredibly complex, that have a large number of working parts without actually using any virtual machines or traditional components within our cloud-based application. We can have all of our networking, all of our database, all of our processing capability done with platform as a service or functions as a service type capability. So this is what something like that looks like. So from the perspective of how we operate in this situation, we've got a user that's using an API gateway. So they might be using a RESTful API. So remember, we spoke about this a little bit last week. RESTful APIs are essentially APIs where we utilize web technology. So get and put from HTTP or HTTPS to send and receive information from an application interface. Here, the API gateway speaks to Lambda. It sends information through, which will then retrieve information, historical information from a AWS S3 instance, or pull information from a live weather API, right, or something else that's within the environment. If we've got a physical device that's connected, that's handing out information or anything like that as well, or interacting with other AWS Lambda instances as well. All right, so we've, again, can build very sophisticated applications by joining together a bunch of these capabilities. And it can work well in a microservices architecture as well. So just in terms of, so one quick thing. So just before I launch into containers, was there anything I need to look at from before we look into this one? So a question from Raymond. Does cloud support auto scaling up and down depending upon load during the day? For example, during peak hours of the day, scale up is down and off peak scale down is done. Yes. So there's a whole range of capabilities of managing scaling utilizing load balancers within any of the cloud environments. So they all support it, and we can do it, for example, based upon if we've got front-end web servers and application servers, we can have load balancers in front of them, and we can add instances based off, for example, the number of requests that we've got coming in. If we're feeding information coming in from a message queue, we could build up the number of instances based upon that. We can utilize CPU information about how the load coming through is, or in the situation that you're talking about, where you know that you expect a certain amount of load at particular times of the day, you can set time-based instances of how these work, either on a daily basis or because you expect to require a large amount of processing within your environment at the end of month or end of quarter or something like that. So those scaling options are absolutely there in a wide range of ways. So you're able to deal with any level of scaling, even using custom information that's coming in from your own environment to specify how many servers that you need. So question come through, do you see any weakness in serverless? All right, so one of the things is it's not a traditional deployment methodology, right? So there's nothing particularly wrong with not being traditional, but companies still understand servers that are doing a particular function. So whilst the applications will run exceptionally well in serverless, you can create sophisticated application architectures. For a lot of people, I think that there's still not a level of trust because there's not something that's sitting there. It's almost like magic of how you request something to do some code and it goes away and does it. Right? So I think that would probably be the biggest downside at the moment, is just the lack of trust and acceptance from an architectural standpoint rather than a technological limitation of the platform itself. The other side of it is you're also putting a layer of abstraction on a layer of abstraction on a layer of abstraction, right? So if something goes wrong in a really weird way, it then becomes much more difficult to debug. I'm not saying that it will or it should, but there's the possibility that you could have something very strange with a particular configuration based upon multiple layers of abstraction. That means that you don't know what the machines are doing because the machines are talking to each other 3 levels down and they're causing your problem at the layer that you can actually see. All right. So again, that also ties back to an acceptance of the architectural platform standards and views on how you deploy these applications, because there's a need for some people to be able to understand and conceptualize what servers are doing on a case-by-case basis as well. And when wouldn't you try to set up a business using serverless? All right, so this is particularly when we're looking at traditional applications. All right, so if we've got traditional applications, we talked about the 7 R's last week of basically looking at everything from rebuilding or replatforming to retiring our applications. And as part of that, we need to understand what our application is doing. Right? So if we're building a brand new application, then we can work from the ground up on an architectural level to deploy the application as we see fit. Right? So we're not constrained by anything on how we deploy an application. So serverless could be a great fit for how we create a brand new application. On the converse, if we've got an existing application that we're looking to make cloud native, so we've got a bunch of components that are sitting within virtual machines within our own data center, then it may make more sense to take some components of that application and convert them into containers, to take some components of it and keep them as virtual machines, and even take some components and completely rewrite them as serverless. But that's the big barrier for a lot of people with serverless, is that you need to completely rewrite it to be a serverless component, because most applications are built so that they run on a particular server in the way that they accept traffic and it comes in. So it needs a complete re-architecture and a different way of deploying the application component themselves. Okay, so looking now at containers. So first of all, there's a course on this that I run, which is the Containers and Virtualization course. So if you're interested in microservices, Docker, containers, etc., then we run this course once a year. So come and join me. Secondly, what is a container? So I mentioned them just a moment ago when we were talking about serverless. We started off with physical machines where we run on mainframes or large scale Windows boxes or anything like that. And we moved from physical servers to virtual machines. There's the capability to run serverless that we've just spoken about. And something in between virtual machines and serverless is containers. It's a cut down version of a virtual machine, essentially. So we share a kernel across all of the containers that are running on a particular system, but the containers themselves are a thin or lean version of virtualization on the platform. The big advantage we have with containers is that the software that we deploy within containers, we have all of the libraries and software and capability we need to run that application within the container itself. So we don't have an issue. I know that I used to be a Windows administrator quite a while ago, and the things like the .NET libraries that would be part of a server. If you tried to run two different versions of the .NET libraries on the server, or Java libraries or something like that, because you had multiple applications, you could run into a heap of problems. Right? So making sure that all of those libraries and software dependencies are wrapped up together with the application is what we're doing with the container, so that we know when it runs in a development environment, when it runs in a QA lab, when it runs in the ongoing test environment and staging environment before it goes to production, it'll work exactly the same each point along the way. And then when it goes to production, we're much more confident of how it gets deployed, because all of those components are available, they operate, but we also have a level of confidence, again, because we're dealing with digital changes within the environment rather than manual ones. We're deploying applications utilizing digital assets, and we're not expecting people to change IP addresses to install application components or anything like that. So the more that we can remove humans from actually dealing with change management, the quicker we can get change out the door, which means that the quicker business can enact change into the marketplace and get a return on investment. So these containers started with Linux technology. What we termed as jails, CH root within Linux server. And this was the capability of just running web servers without essentially any other rights to the system, and segregating those components or application components from the rest of the environment. And that built out further into what we saw as containers. And again, not a full virtualized system. We have a shared kernel, but all of the major components from an application perspective are separate. The other major view that we have with our containers is we expect them to be disposable or ephemeral. Right? So that when we update the application, we don't go in and update the components within the container. We throw the container away and load a new one in its place. Right? And that means that we don't have a big problem with change management, because if something doesn't work when we load the new software in, we can just load the old one back quite easily. Oops. So I'll just skip over that. So a quick view of what things look like within Docker. We have a client system where we're sending information across, sending our command line requests through to the Docker host, pulling information backwards and forwards. On there, we have a Docker daemon that runs, waiting for commands to be seen, and controls how they start up and the information they start up with. We have images. So these are basically, you can think of them like a CD where you would install software from. So this is the bare information of how we have applications run. We pull that information from a registry, or we build it ourselves. So if we have an application such as NGINX or MySQL, we pull the image, which is essentially that read-only software from a registry, or again, we can create it ourselves. And when we start running that image, it's running as a container within its own environment. Right? And again, we can separate out the storage and other capabilities within there from a container perspective. But when we run the container and want to stop it, we can keep the storage separate and put in place a new updated container in its place, utilizing the storage that the old container was. And so we don't need to throw away all the data or back it up or anything like that. We can quickly replace a container with an updated version and keep it running with the data that the old version was at the same time. So when we're looking at Docker, Docker's the manager. So this is where, again, we start, stop, create, or destroy our containers. It gives us access and control of all of our resources. We deal with our security and IO. So the containers themselves are what are actually running the programs: execution, memory, running software, etc. So, but why, again, do we want to worry with containers? So first of all, we want to match the life cycle of the container with the life cycle of the software. So this is also moving towards, as you see in the bottom here, of microservices, of breaking down the components of our broader applications into individual bite-sized chunks and making it so that those chunks can have a smaller development team, a faster release cycle, and easier to test, deploy, and manage on an ongoing basis. We want to have increased flexibility based off the back of those capabilities as well. If we have a bug that is found, or we've got new capability that needs to be put in, we can add that to a microservices type framework utilizing containers really quickly. We have the rebuild capability of, if there's any problems, we just throw it away as an ephemeral or temporary application component, and we can rebuild it and reuse it. Excuse me. And we've got clear separation between the data and the application piece. So the container that's launched from an image, all of the application components, can be separate from all of the data that's stored in the way that we deploy these things. We've also got greater organizational agility and innovation, and the ability to tie in with continuous integration and continuous deployment type pipelines. And again, the move to microservices. So more broadly, in regards to containers, the biggest move that we have over the last 5 years or so is moving not only from a Docker perspective, but moving to Kubernetes. The connection between containers and Kubernetes is that containers do all the work, as you've seen here, we've spoken about. Kubernetes is the orchestration engine for how you manage those things. And tying in with technologies such as Helm gives us the capability to deploy entire applications across multiple data centers, across multiple cloud environments, or anything else. So it allows us to deploy applications confidently, accurately, and know how they're going to operate when you deploy them. All right, so again, Kubernetes is an orchestration engine for containers that we've spoken about, and we still utilize technology such as Docker sitting underneath there for the way that we deploy the actual application components of those containers. All right, so that brings us to question time. How are we going for questions, Jack?
Well, we have quite a number of them. I think some of them are ones that you have kind of answered a little bit in some of the content, but such as, where does Kubernetes fit into the picture of containers? I feel that has been answered. Yeah, would you like to perhaps kind of group them into a couple of kind of overall umbrellas of questions? I would say there's a fair few that are quite specific to AWS. If you'd like to go into some of those, I can read them out to you if you'd like.
Yeah, so let's go through those to start with.
Okay, so yeah, so there's a couple actually about AWS versus Azure. So Sertan says, what's the equivalent of AWS VPC in Azure world?
I had this up before. If you have a look at the link in regards to the equivalent component, then you'll be able to see from the link that I had at the start of the session in the introduction. So actually, I can just bring that up now. So when we come across, have a look at this. But yeah, if you have a look, I'll push Sertan to have a look across there. I can't remember off the top of my head. I'm sure someone will come through. There you go. VNets, Azure VNets.
Excellent, excellent. And just sorry, letting everyone know that we are going to stop taking new questions at the moment. Unfortunately, we probably won't be able to answer every single question that remains in the next 15 minutes, but we'll do our best so that we can finish in time. And as always, there is the discussion forum available to everybody at any time where you can put your questions for discussion with the other participants. So yeah, there are a couple as well around encryption. So somebody's asking, so Leo says, while attending an AWS course, I was advised that companies should not depend on the cloud provider to encrypt, but recommend the company use their own encryption and to manage the encryption keys. Now, is this quite similar to what you were talking about earlier around individual encryption?
Yeah, so it really comes down to what the requirements are for the business and how secure their systems are. So within AWS, for example, and the other cloud providers, there's default encryption at a whole number of layers that utilize the cloud capabilities to secure that by default. All right, so that encryption is completely fine. Right, so for most applications and users, they don't need to use a separate capability. If you want to go a little bit further, there's cloud provided HSMs, hardware security modules, that you can utilize within the environment, or you can utilize your own keys using key management for how you deploy them as well. Finally, you can have your own external security body and encrypt all of your data with your own keys, so that anyone who gets access to any data at rest, for example, so if they managed to get hold of a hard disk that had your data on, there'd be no possible way that they could decrypt it. So again, these all come with trade-offs though, that it requires more time, more effort. So if you don't need to do these things for your line of business work, they will create more work and more complexity to your environment, but they also introduce some risk of themselves, because if you lose your keys or lose access to it, or someone heads off and deletes something in your own office, you can lose access to the entirety of your data, because there's nothing that AWS can do if you're using your own keys to recover any of your data from backups or from anything else.
Excellent. Thank you very much, Tim. Now, a really brief one probably. We've got from Derek asked, is security configuration vendor specific, i.e. Cisco, Fortinet, Checkpoint, etc.?
Yeah, so the security, so the different vendors. So as part of, sorry, I'll take a step back. First of all, there's default capabilities within all of the cloud from a security perspective. So there's web application firewalls, for example, that are available in all the vendors. We've got security group type capabilities and network access control lists and other capabilities that are built into cloud capability. Across all of the clouds, we then have a marketplace where you can purchase from third-party vendors' capabilities, such as from Fortinet or from Cisco, from a security perspective, to provide certain capability. Now, these often can do the same sort of things that you can do with native cloud capability, But the advantage that they have for a lot of businesses is that there's a big investment in security training, with logging, the way that you keep track of what's happening across your entire environment, utilizing certain tools that are built into vendors' products. So being able to use the same tools to secure your cloud workloads can make a lot of sense for some large businesses to use those sort of capabilities. So the capabilities are often very similar, and you don't need to use any of those specific ones for deploying regular cloud network operations. But yeah, for specific uses, it's more the edge capabilities and integration within the broader enterprise where I'd expect the most value comes from for customers that choose to use those tools.
Great, thanks so much. Now, we've got a couple of questions about disaster recovery, and I might tie a couple together because they're about disaster recovery and risk minimization. Sarah asks if it's possible to audit the disaster recovery capability of cloud-hosted applications and data. And then Song asks how to reduce country risk in terms of you are using cloud services. For instance, your server hosts in an EU country and Russia attacks EU country. Entirely hypothetical, complete fantasy scenarios all around.
Yeah, so it was the first one again, the
whether it's possible to audit the disaster recovery capability.
Yeah. So auditing that is the audit capability from a disaster recovery stance is more so around the architecture you have in place. So in many organizations, you need to be able to do some form of dry run or hot cutover or something like that to actually test that disaster recovery works, in which case, yes, you can absolutely do that in a cloud environment, and in some ways in a more simple manner than you would in a traditional data center type environment. But from an audit perspective of ensuring that your systems are up to date, etc., you can check to make sure that data is replicated from an audit perspective. You can check to make sure that you've got multiple components and the ability to spin up different components. You can have audit trails that show the capabilities or the life of any of your assets within your cloud environment. But from a BCP perspective, for DR and being able to audit the environment, a lot of that will come down to the capability to understand the architecture of how you're deploying that disaster recovery. And a lot of the disaster recovery methodologies, the way that you deploy systems, is different in the cloud world than it is in a standard data center. In many cases, many businesses choose to use a trust-based model of deploying applications rather than the traditional view of having N+1 for everything to make sure that you don't run into any failover issues. So some slightly different ways that you look to deploy the applications. Now, so in regards to the other question, where is it?
The question has been taken out. Oh no, it's back in, asking how. Oh, nope, sorry. The Q&A section just did something interesting. I was asking if there is a way to minimize risk in terms of the storage location of your data, with a hypothetical scenario about a hypothetical country being hypothetically attacked.
Yeah, so the biggest one there is that all of the cloud service providers have multiple areas around the world. And especially for something like AWS S3 or Amazon S3, as soon as you write some data to a particular location, it's replicated across all of the availability zones in that area. So if you had, for example, an Australian-based site of storing some particular data, a backup or something like that, it's automatically replicated to 3 physical locations that are separated by enough distance that you're not going to run into a direct problem with any of those. Now, if that location was to get invaded and cause both potential risk to the data center, but also risk to network access being cut off, that's where people look towards spreading their environment from a storage perspective outside of a particular region. So this then comes back to one of the questions we had earlier of being able to ensure that we, in some cases, don't have data outside of our country or outside of our region. So we need to be careful to balance our compliance requirements with any potential need to make sure that we don't lose access to data in the longer term. So in some areas we can be more comforted about that. So the view from AWS, the standard line, is that they've got 11 nines of data durability, and so what that equates to is it's like 60 quadrillion years or something like that it would take to lose a single bit, something along those sort of lines. So it's the expectation from the cloud service providers is they're not going to lose your data, but you may lose access to them for a period of time if a major warfare breaks out.
Right, thank you so much. Now, we only have time for one final question. Apologies to anybody that had a burning question that wasn't able to have that answered. I will direct you to the forums at learn.itmasters.edu.au. And Tim, I cannot handle the pressure of choosing the final question, so I'm going to throw that over to you. I'm sorry, it's a cowardly move, but you are the expert.
Yeah, so if we go through and have a look at I'm assuming that someone's mentioned here the ODI model, which I am going to assume is the OSI model, and asking whether that's important to networking. And the answer there is yes. All right, so this is something that's been around for a very long period of time. It was around from before I even started in IT many years ago, and it gives a clear view of how different layers of applications of networking capability, etc., talk to each other. And so knowing what layer we're talking at is of particular interest, and it comes up in AWS exams. It comes up in the way that we talk with networking people and application people, etc. So, for example, we might have a layer 7 firewall, which means that we're running at the application level. And so that we're actually inspecting application level components that are coming into the environment. So this is our web application firewall, for example, where we're able to do inspections of data and not just block based upon ports. So a level 4 level load balancer is where we're doing load balancing based upon just the network addresses and the ports, etc., that are coming across the network. So, so those things are important. They're still pertinent to what we're doing, and yes, it's also something that you'd be expected to learn the OSI model.
Fantastic. Thank you so much, Tim. And again, apologies to anybody who was not able to have their questions answered, but I trust that the conversation will be very free-flowing, very engaging, highly engaging on the forums this week. Thank you so much to Tim for presenting another fantastic webinar with us. Thank you, Hannah and Kit, for the admin and tech support roles. And thank you so much to all of our wonderful participants. Thanks for attending. Just another reminder, jump on learn.itmasters.edu.au. There were some questions as well, which were not answered because they were answered quite in depth in last week's webinar, which is also accessible online at learn.itmasters.edu.au. So thank you very much, everybody. And yeah, well done. We will see you all next week at 7:30 p.m. Australian Eastern Daylight Time. Thanks very much. I'm going to end the recording now.
Thanks, Jack.